Good morning. Good morning. Good morning, everyone. Or afternoon, I guess, depending on where you're coming from. It's still morning for me. Good morning. Thank you all for joining us. As you sign in, we'd love to see who you are and where you're coming from. So you can open up the chat in Zoom and maybe type in your name and location. And if you'd like to add to the conversation, how can we use computer science to make a better world? Thank you for joining us. We're going to leave this open for a few minutes to get maybe a couple minutes so people can join. Awesome. Welcome. Holy family. Crystal Ray. Awesome. Awesome. Welcome from Birmingham, Alabama. Okay. Cool. We got a lot of Holy family. Crystal Ray. Thanks for joining us. Northern California. Lucas, welcome. Cool. A lot. We got a good group from Alabama. I don't think I've actually been to Alabama. That's exciting. Awesome. Thanks for joining us. As you sign in, we'd love to hear who you are. So you in the chat, you can type in your name and location, and we'd love to hear your thoughts on how we can use computer science to make a better world. So if anyone has ideas they'd like to share, I'd love to hear those. We'll get started in a minute. We do want to make sure you have time to do the programming today, but we'll just give another minute. Awesome. We had somebody in the chat saying, I love computer science. I do too. It's why I'm here. It's why we're all here. We're so glad you guys are joining us. We'll just give 3 more seconds here, see if we can get any people trickling in. And we might have people trickling in as we go, and that's okay as well. Cool. Well, we're going to get started here just to make sure you guys have enough time to do your programming, which is the main part of today. So, all right. Awesome. If you just joined, we're going to get started, but we'd love to see who you are, so you can put in your name and location in the chat. And yeah, let's get going here. All right, so welcome to our Coding for a Litter-Free community. Today, we're going to explore how you can use computer science to help solve one of the biggest problems facing our world today, which is litter and waste. And yes, unfortunately, this is a real photo. So my name is Ryan. I am a curriculum developer here at CodeHS. So if you've ever taken a CodeHS course, I'm part of that team who helps write that content. And then we also have my colleague Ursula, who is with us, and she's going to help answer questions that come up today. So if you have questions, we are here to support you guys as you get into the programming. There is a question and answer function in Zoom. That's the best way to ask your questions so we can make sure we answer them. But you can also put them in the chat as well. That is something we'll be able to see throughout the presentation. So before we jump into the topic of the day, we are extremely lucky to have a guest with us. So meet Dr. Columbia Mishra. She is a senior staff systems architect engineer at Maxar Technologies. She has been involved in a lot of fascinating projects over the years, designing spacecrafts and helping bring humans to the moon. So Dr. Mishra, can you tell us a little bit about your journey and how you got into computer science or programming?
Thank you, Ryan. Hi, everyone. Welcome, especially watching this from all over the country. I'm so excited to be here and share my journey as an engineer and my journey as a programmer, coder throughout. By profession, I'm a mechanical engineer, which might seem a little counterintuitive thinking about computer science and coding, but I do numerical research and numerical simulations to predict how our spacecraft designs will function or work or fail, or if they are worthy enough designs, all through numerical simulations. And sometimes we accompany that, a lot of times we accompany that with testing, but we really heavily depend on computation and numerics. So my experience of using codes and writing codes is essentially around solving different complicated partial differential equations for some complicated geometries. And in this case, specifically for spacecrafts. I started out, like most of you, doing GW Basic or some very old types of coding back in the day in middle school, high school. And slowly, when I was in mechanical engineering program, we had a bunch of different classes that required data processing and a lot of different coding classes we had to take in college, like C++, C, and so on. And with that, I got that experience. But it was not until I started doing research is when I did not apply computer science as much. So when I was actually solving for complicated heat transfer or thermal systems or fluid systems is when I started writing codes to solve those partial differential equations. And that's when different numerical techniques, different faster algorithms, etc. came in handy, and I developed the knowledge. I ended up getting a PhD in computational domain. So my PhD was developing computational methods to solve for nanocomposite heat transfer. So even though I'm a mechanical engineer, I have been very much intertwined with the computation side of things in my domain. And I know a lot of people think mechanical engineer, you must be like building things and carrying big blocks around or working in a machine shop, but that's not really how it is. There is a lot of computation side of things, and we need to have those coding capabilities. In fact, most of the jobs that you might see in the future will require you to code. So hope that is a good starting point for a conversation, Ryan.
Yeah, absolutely. I mean, it's so impressive, what you're able to do. And, I think it's fascinating how really all these, you say mechanical engineering, but it really, you wouldn't be able to do your work without the computational power of computers. And, I'm just having a glimpse of, some of the physics and the equations that you have to solve through those equations is pretty wild. And I don't know how people were, years before really the computers were developed, were able to work through these things. So yeah, my first question for you is, being able to leverage that computational power, what about computer science have you really enjoyed, or maybe a favorite part in terms of how you apply it to work, or just maybe personally in your work with, kind of the different things that you've worked through?
Yes. So some of the things that I really enjoyed was the fact that you can use coding to solve for very complicated problems and getting predictions that otherwise you cannot imagine, especially in like nanoscale. And one particular example I would like to share is my time at Intel when I was working as in the computational photolithography. So the idea there was we were solving for light's behavior around corners at the nanoscale to manufacture things, transistors that are nanometer length scale. So that really just required a lot of coding. So we had Maxwell's equations to solve. We used C++ and we used Python. And just during the time, I feel like the best part for me was that we could put in different parameters. So if all the physics was not entirely resolved, so we would have to come up with different parameters that can quantify what the problem really is without actually solving for the exact PDE. So a lot of iterative methods we were applying. So what I really liked is sometimes I would think of parameters based on the program and the like discretized equations, and then I was successfully able to predict what would be the correct mask corrections and give it to a engineer who actually went into the clean room and prepared, like, manufactured the masks and actually build the product. And when they would bring us those images, the scanning electron microscope images of those gates or the transistors, and we'll look at it and realize that the parameters were successful in determining the correct mask corrections. And that was very satisfying and fulfilling. And it was a lot of just hours of coding and, looking at if you're, but I would also say, make one caveat that coding is not just, you just code and that's it. It has to do something that connects. So I know that you all are working towards a litter free community. So how does the code serve that purpose? So keeping that in mind. So coding not for the just sake of it, but also having a meaningful impact on the problem that you're trying to solve. And that gave me a lot of satisfaction. And my job really just required me to sit in front of the computer all day long, keep, writing codes, making these design corrections, iterate again and again. And each of the masks that we designed was worth probably $1 million. So I single-handedly, we used to joke around amongst the engineers that we single-handedly, fresh out of grad school, we have the ability to mess up $1 million with one coding mistake. Or if we push accidentally the wrong version of the code, if you don't do good version control organization and things like that, so how you could mess it up. So it was very high impact, high value, and that's what I really enjoyed about the coding process, coding for a purpose.
Yeah, that's absolutely fascinating. And, the ability to code, I mean, it reminds me of like a lot of the machine learning ideas where you can implement code and work with parameters without really understanding, what's going beyond, behind the scenes. Yeah, so and the fact that you could iterate and work with the code before having to make each $1 million mask, is huge. Well, thank you for sharing that. So for those who are with us, we do have some time for your questions. If you have questions for her, you can put them in the question and answer or put them in the chat, and she would be happy to answer them. So we have a few minutes for that, and I'll throw out here another question while we wait. What aspect of computer science do you find most challenging for yourself?
I think the most challenging part for me is the validation. Essentially understanding what you are doing, if it's correct or not, because you can do garbage in, garbage out, right? So you can code literally anything and you would get some results, but is the result even correct? That kind of checking, I think, is important. So in my field of work, I do simulations of spacecraft. And what I find is very important for me is making sure the results I'm seeing are they correct or not? And if I'm missing something. So that is the aspect I think is very important, because we make a lot of assumptions in our approximation of the problem. So it's a very complex system and there are millions of cells, as in there are billions of discretized equations. So it's like a numerical extensive operation. And to have such a numerically expensive operation, run hours of codes and get garbage, that's kind of challenging. And checking that is very important. So validation part is something I pay a lot of attention to. And I think making sure that your boundary conditions and you have some other control that you can compare your solution with, like simply put, if you are simulating, in my context, if you're simulating heat transfer across a solid block, do the temperature contours make sense from the output, and then making sure that the code, like especially if you're writing your own code and not using a commercial package, making sure before you address a complicated geometry, does it work for a simple case? So those kind of checks, they can be tedious and they might feel like, oh, I have to do so much, but that's very important. And I think it's challenging, but it's very important work.
Yeah, awesome. So I think you answered one student question that came in asking about kind of challenges of the career right now. Another student has asked, how long did it take you to learn coding? So curious if you had any insight there.
Yeah, so I think coding, the basic definition is more or less all of us are coding all the time, right? Simply by the definition, like you code how you send a chat, you code how you operate a simple machine these days. So all of these are basically simple instructions that you're giving to a machine, and that's really coding. So you are literally coding. All of us are coding. But to talk about formal coding experience, when I was in school, like you all, in middle school, high school, we had computer science classes and we got coding lessons. So we did codes in Fortran, in GW Basic, and so on. It took me, the whatever time was in the class to learn about it. I would share with you an experience where I had to learn coding very fast, a different language very fast in grad school. So when I was in my PhD program, I was doing experiments and theoretical work in the beginning of my PhD, probably first couple of years. And I was coding somewhat in MATLAB, but not really using coding every day as a mechanical engineer. And then my research changed, and then I had to learn C++. I spent probably a few months just immersing myself into the language and understanding and writing my own solver suite and everything. But once you learn one language, you can translate. It's very transferable. So if you understand the logic and algorithms, or if you just learn how to write down the steps, then there are, I think, platforms these days that can translate that into the right syntax for you also, right? And then you can learn, it's a different language. So you just learn the syntax or the grammar of that language, basically. So I would say, give yourself maybe a few months, and the more you practice, you will do better. But if you don't practice, you'll forget. And I think it's not like it's not like swimming that it just remember. It's a little different.
Yeah, and I think your comment of we are all really programming in that we're giving commands to technology, and that even if it's not a syntax language, that is programming of types, and even the stuff we'll do today is going to start introducing some of the major concepts. So we have time for maybe one more question, because I do want to make sure we have time for you guys to program. So there are a lot of great questions. I think one question that's maybe a little different. So if computer science is not available at the school, or if you're not able to take a computer science class due to scheduling, what sort of classes would you think could help prepare for computer science degree, or thinking, or getting into some of the things that you've done?
Yeah, I think there are a lot of open source programs. Like you can try Python, for example. It's open source. Anybody can download Anaconda, right? You can start coding, and there are a lot of online forums. And I think Ryan, you might be able to help with some of the resources for the students. But Python is free. It's you can download the program on your computer. You can just Google search, anything, any simple code. Like there are so many free online resources on this. If you want to learn, you would find many different options. And I don't know what other languages. So I'm more towards scientific programming, like scientific computing. So I use C++, Python, and other commercial codes related to computational fluid dynamics. But for everything I have used so far, even MATLAB, I think is free for students, depending on the schools. MATLAB is a very easy tool you can do a lot of graphics, etc. And yeah, for all these options, you can just do Google online search. There are lots of forums. Any particular thing that is in vogue these days, Ryan, that you want to mention?
Yeah, and honestly, what we're going to be doing today is going to be a great intro into programming. And our site, all of our curriculum on CodeHS is available for free. And so that's honestly a great way to get into it. And I think what's something different, and I think you alluded to it, than a lot of other subjects is that you can do coding for fun. You can create your own games and your own websites and your own applications. And a lot of people do it outside of school. And so using these online resources, whether through CodeHS or not, if you have access to a computer, you can start learning to program your own sort of fun things on your own. And so I think that's different than maybe a physics or a math or a chemistry where you need to be in school to do some of those things. So thank you guys for your questions. Okay, we'll do one more because I really like this one. Do you have anyone who inspired you to code? Was there anyone, yeah, that kind of inspired you?
For me, it was really just trying to get answers to my physics problems that inspired me to code.
Nice.
For me, it was more like coding has a purpose, and I have a complex problem. I cannot solve it analytically, and there are no analytical solutions yet for the Navier-Stokes equation. That's an open problem, kids. You want to solve. But so what people do is they write, there are solutions for different special cases under different approximations, but no real solutions. So you need to take the help of computation. And one of the other things, like I am slowly getting into the little bit of machine learning and AI myself, is because I'm motivated by the physics. So I'm very interested, and it's kind of one of the questions, like hardest thing right now. One of the hardest things right now is the different material challenges. We don't necessarily have the right material properties to address different challenges of the lunar orbit, for instance. So now I want to take the help of machine learning, computation, and AI to predict what kind of material properties do I need to be out there in the world that I could use to solve my problem. So it's a little research question, and probably allows me to work with other material scientists to figure out what kind of properties would be useful. So that's what really inspires me to code, because it's an excellent tool. It's an excellent way to get answers. And there are so many problems I could have the help on. And you can't rely on just simple hand calculations for everything, like Ryan was mentioning.
Yeah, absolutely. And that, I mean, it reminded me that my first program that I ever wrote was in high school on the graphing calculator, just writing a quadratic formula solving program, because I was tired of solving it by hand. So I just wrote the little program, and then it solved it for me. So, it can be very simple, things that are just helpful for you guys. Awesome. So let's thank you, first of all, Dr. Mishra. That was awesome. If we have any more time at the end, you don't have to stick around, but we love these student questions. And if there are some that weren't answered, we can also try to send those out after. So thank you again. We're going to hop into our main activity here. But if you haven't read, we have an article, an interview with Dr. Mishra on our website, Coding in the Wild, which we can share this link with you. And she goes into a little more details of what she's currently working on and kind of her path. So be sure to check that out. It's a great article. And yeah, just so grateful for you to be here. So thank you.
Thank you so much, Ryan. Thank you so much for all the questions. Happy coding, solve lots of problems with coding. And if you have any questions, like send it here, and then hopefully Ryan will be able to send it off to me.
Yeah.
And thank you all.
Yeah, thank you so much. All right, so now to today's topic, creating a litter-free environment and how can we use computer science to help. So we're going to look at two examples that we'll use as inspiration for our coding today. So the first one I really like, I think it's fascinating, it's called the Interceptor. It's created by an ocean cleanup organization. And so what they did after looking at a lot of data, they realized that most of the pollution that enters the ocean from rivers comes from only a small handful of really polluted rivers. So they decided to build the Interceptor and place it in front of these select rivers. And it collects the trash as it flows down the river, drops it into dumpsters, which are then ferried to a collection site. The amazing thing is that through the programming and artificial intelligence that they developed, this process is almost completely automated, meaning they don't need staff on board monitoring and doing the work. So this is an awesome, awesome project, and there's more online if you want to learn about the Interceptor. The other project, the other example I want to point out here is on a smaller scale, but similar idea in the water. It's called the Waste Shark. And it's another great example how people have used computer science and programming to decrease litter. So this is a drone that moves around in the water collecting trash. And so you can control it using either a remote control, or you can it can move around on autopilot as well, kind of similar to the Roombas, if you've ever seen those vacuum cleaners, which I guess is cleaning up trash in your house, all automated. So we're going to use this as our inspiration for our programming today. So in today's hour of code, we're going to learn the basics of Python. Dr. Mishra mentioned Python. So we're going to get started with the introduction to the basics, and then you'll have a chance to do some coding. So right now, you don't need to be logged into anything. Just follow along, and then we'll give you directions on where to go. Okay, so programming or coding, really simply is giving commands to a computer. And so, which is very similar to giving commands to a dog. So meet Carol. Carol is a dog who listens to your commands. Carol speaks and understands a programming language called Python. So lucky for us, Python is a great language for beginners, and it's also used in the scientific industry, machine learning industry, data science industry, so it's used throughout. And it's also used in a lot of companies that you know, like Google, Instagram, YouTube, and here at CodeHS, we use Python as well. So this language you're going to start learning is used everywhere. It's one of the most popular languages right now. So here's Carol's world. It is a grid world with walls around the edges, and each dot represents a space where Carol can stand on. Unfortunately, just like in our world, Carol's world, litter has been a problem and is making it difficult for Carol to survive. You'll have to use your imagination a little bit. The trash in Carol's world turns out to be yellow tennis balls. So how can we use coding to help Carol clean up her community? Just like we can control the Waste Shark to move around and pick up litter, we can give Carol commands to have her move around and pick up the trash or tennis balls. So Carol knows 5 commands. Carol knows how to move, turn left, turn right, turn around, and take up a ball. The move command moves Carol 1 space forward. Turn left command makes Carol turn 90 degrees to the left. Turn right has her turn right 90 degrees. And turn around has her face the other direction. And it's okay that she's upside down. She's okay with that. And if there is a ball or piece of trash where Carol is standing, you can use the take ball command to pick up the tennis ball from the space that she's standing on. So those are the 5 commands that you'll be working with. And it turns out that computers and Carol are very picky. So when you give commands to Carol, you have to give the command in a very specific way. Notice there are no spaces in the command. There are no capital letters. An underscore is between different words. And there's an open and closed parentheses at the end of the command. And that has to be there in order for Carol to recognize that command. And so it might take you some time to get used to writing this way. And this is called the syntax of a programming language. But that's because you're learning a new language. The more you practice, the more natural it will become. and you'll just be used to writing commands like this. So throughout this hour of code, you will learn a few important programming concepts. You'll learn the basic commands that we just went over, for loops and if statements. You will use these strategies to complete the cleanup challenges and help Carol pick up litter in her community. The cleanup challenges will get increasingly difficult as you go, so be prepared to use your problem-solving skills. Okay, so now that you know the basics, let's go to the Carol world in the code editor on CodeHS and pick up a few pieces of trash. So I'm going to show you this example, and this is the first one we'll do together. And then you're going to be doing similar examples that will get harder as you go, as you learn new concepts. So what you're seeing here is our CodeHS editor, if you've never been on our site before. So for Carol, on this left side, this is the end world that we want the world to look like when we're done programming. And on the right, this is what it's starting at. So you'll notice that we want to move Carol to the right and pick up that tennis ball ending on this location. So that's our goal with our programming. There's a section called Quick Docs that you can reference the commands that you'll need to know. So that's very useful. You can run the code here once we type it in and reset it. This toggle changes how fast the code runs. And when you're done and you want to move on to the next activity, you can click continue, or it may say submit and continue, and that'll move you to the next activity. So on the bottom here are all the activities in the hour of code. So this is the example we're doing now. And then you're going to start with cleanup challenge level 1, which we'll send a direct link to so you can get started there. And then you'll be able to work through increasing activities. And then at the end, there's also another HTML website design activity for this hour of code. So after today, if you want to keep working on it, you could design your own website as well with these ending activities. Okay, so let's type here our first program. So we want to move Carol, looks like 1, 2, 3 spaces to the right and pick up our tennis ball and then end 1 space over. So we want to end down there. So let's start just with our first move command. And if I type move, oops, you'll see there's an error. Okay, so nothing actually happened, and that's because I forgot the parentheses after the command. So if I now run this again, let me reset it and run it. So Carol does move. I still get an error message because the ending world doesn't match what we're trying to go. Okay, so let's work on this. So I need to move Carol 1, 2 more times. So move. And that should put Carol on the tennis ball. Okay, so then at that point, I'm going to use this take ball command. So take ball, remember it's all lowercase and there's that underscore. So that, oops, I need to reset it. Don't forget to reset after each time you try it. Okay, so I picked up the tennis ball. So I'm close. I just need to move Carol 1 more spot over. So if I have a final move here, let's see, is this going to do it? Awesome. So it says I did it. My ending world matches what I'm trying to do. So there's our first program. So you can see it's very simple. And even though this seems, especially simple, this is really the basics of programming. It's telling very explicit commands for the computer to follow. All right. So now it's going to be your turn. So the rest of the time here, we have about 20-25 minutes for you guys to work on your code, which is plenty of time to work through a couple, 2 or 3 activities. So if you have a CodeHS account, you can log into that, and your teacher is going to probably have instructions for you here. You don't need a CodeHS account, but it is recommended if you have one to log in, because you'll be able to save your work and return to it on a future day. Our team is going to send a link in the chat, and that link will bring you right to the challenge problem, cleanup challenge level 1. And that's the first activity that you're going to work on. So whether you have an account or not, either way, this link will bring you right to this activity and you'll start programming. So I'll leave this up. I will put up a screenshot of the editor as well, just with some helpful little notes there, and I'll leave that up as you're programming. But feel free to either ask questions to your teacher, or we'll be here while you're programming. So if you want to ask questions in the question and answer or the chat, we will be sure to answer them. All right, so I release you. I'm excited. And have fun, and we'll come back together at the end just to kind of sign off, but you have at least 20 minutes or so to work through the activities. And just as a reminder, the activities are all down here at the bottom, so you can kind of see where you are. So you'll start with the cleanup challenge level 1, and then you'll progress through the different challenges. So there's a video and some examples showing new skills, and then there's challenge number 2, and then a video, new skills, and a third challenge, and then an ultimate challenge. So however far you get in our time is great, and you can always continue after. Cool. Now I will be quiet and let you guys go. All right, we're nearing the end of our time together on this webinar in the Hour of Code. So hopefully you guys were able to work through a few of the programming exercises and learn some things and had fun. So in terms of what's next, you can still have access to all the programming activities. So if you didn't finish, definitely keep working on it. If you're logged into CodeHS, you can return back to your saved code. If not, if you leave the window open, you can always continue, or if you just visit the link, you can reopen it and continue where you left off. So definitely encourage you to keep working on things. As I mentioned before, there's a what was it? I can show the slide. These last section of activities after the cleanup challenge, there's a group of activities that help walk you through how to create a website in terms of showing information about cleanup or litter or something on theme for cleaning up communities. But it also is great information on the basics of HTML and creating a website. So definitely would check that out if you're interested. Yeah, we want to thank you all for joining. There was one question who we didn't answer, and it was kind of what's something important that we need to know. And I think Dr. Mishra would probably agree. And just in learning a new language, it's persistence, and it's just sticking with it. And it might be challenging at times, but if you just keep working at it, then you will get to, you'll be able to create some awesome things. And so there's a lot of fun projects that are simple and, definitely more complex as you go on. So keep working at it. Even if you're not a programmer, there's a lot you can do just having a basic understanding of computer science. So thank you all for joining us, and we wish you the best of luck. Enjoy the rest of 2021 and keep coding. All right, take care.